to the next part. So now I have 55 equals 2 to the power x plus 1. It's an exponential equation. Can I convert left and right to same base? There's no way, right? 55 is not a base 2 number, okay? Because we cannot use the same base technique or the same base method here. We must use logarithms to solve it. Okay, so finally you're going to kind of see the importance of logarithms. So what I do is, as soon as I recognize it's not same base, it's called we take logarithms of both sides. And when I say we take logarithms, you log both sides of the equation, and how you show that is you say, okay, I'm going to put log of 55 or 55 in logarithmic form. Whatever I do to one side, I do to the other. So I'm going to log 2. So it's logging both sides. I logged 55, I logged the 2 to the exponent x plus 1. When I took logs of both sides, notice what base I used. I used 10. Why did I use 10? So that it's a common log, and then so I can use my calculator if I have to. And most times for these tough ones, you're going to have to use your calculator. That's why they were programmed for logs to solve the tough equations. The only ones I can solve without a calculator are the same base ones, pretty much. Okay, so I did base 10, so I can use my calculator. Now, notice what happens. First of all, a log, a variable that was in the exponent that was unknown, can you see that in one step, it's not going to be an exponent anymore? Agreed? Because look what happens. I've got log 2 to the x plus 1. When I log both sides, what do my laws of logs allow me to do with an exponent? Look at this last one. I can take an exponent in a log statement and it just becomes, seamlessly, it just becomes a coefficient. So then I can rewrite my statement. Log 55 will equal, okay, this comes down as a coefficient. See how easy that was? And that's a beautiful thing, right? Because now your variable isn't in the untouchable exponent area, it's down as a coefficient. It's down on solving level, right? Where we're used to seeing our variables. All right, what do you think we would do next? Sorry? What did you say, Adam? What did you say, Carl? Yeah, like, I need to get, I'm trying to solve for x, right? So I got to break him out of his brackets. I may as well multiply through to get rid of the brackets. And then let's see what happens. Because right now he's trapped in those brackets. So I get x log 2 plus 1 log 2. Okay. Basically, it's just, even though it's got logs in it, it's a linear equation, right? So here's my log. I have to isolate them. What would you do next in order to isolate x? I've got x times log 2 plus log 2. I don't think I can multiply anymore. Yeah, I think someone said move this over. Like, think about it. What if you had, forget the log 55, log 2, what if I just had this? If I just had the equation right now, and I had 55 equals 2x plus 2, what would you do? You'd move the 2 over, right? So same thing. Move the 2 over first, but it's not a 2, it's a log 2, so we move that over. So then I get log of 55 minus log of 2 equals x log 2. So I've almost got x isolated, right? Now what do I have to do? Sorry? Ibby, what do I have to do? I've got x times log 2. How do I get x by himself? Oh, thank you. What do I do now? Not subtract. X is being multiplied by log 2. Divide by log 2, right? So I divide out my log by log 2. Whatever I do to one side, I do to the other. So finally, X equals log 55 minus log 2, all divided by log 2. Now, I'm going to tell you, before you pick your calculator up, you got to be careful. Not only do D and I, myself, have to close these brackets off, but this whole piece has to be divided by log 2. So this whole piece, you've got to think of it as being bracketed off. Either it's bracketed off, or you can do this subtraction and then hit an equal sign before you do your division. The easiest thing is probably to put these guys in brackets. Okay?
What if we don't put log sign and
yeah, so you're going to do, it's going to look like bracket log 55, I have to close my bracket, minus log 2, I have to close 2 brackets, right? Divided by log 2. Now, I have to use lots of brackets with this calculator. I don't know if you guys have to. Probably all of you should be using these brackets. I know some of you, if you have the little sharps, you probably don't have those inside brackets like I do. Play around with your calculator till you get the answer of 4.781. And again, this part of the course, it's almost just exploring how your calculator works, because everyone works a little different. So you have to figure out how to enter logs into your calculator. John?
What if I did in the second step, x plus 1, I should divide by log 2, divide by
Oh, sure, yeah, you can do that. Right, you could do that too, right? Okay, so what John said, let's look at that. As long as it's mathematically sound, right? Let's see. So here, this is what John did. Log 55, that's true, you could do that, divided by log 2, right? And that leaves you with x plus 1. Then you could do log 55 divided by log 2 minus 1 equals x. Yeah, that's mathematically sound, isn't it? And you should get the same answer, that's good. So log 55 divided by log 2 equals minus 1, 4.781. Perfect. Yeah, either way. Did anyone else do it this way? Yeah? Yeah, that's fine. That one works nicely because this is a fairly simple equation. I don't think you'll be able to use that method for all of them, right? But when you can use it, that looks good. Let's jump to F. I want to do F first before we do E. Let's take a look at F. So you always say to yourself, okay, I've got two sides, it's an exponential equation. Is there any way I could use same base? Base 5, base 45, what do you think? Is it possible to put the two in the same base? Yeah? Base 5? Okay, 5 squared is 25, 5 cubed is 125. Nope. As much as you think you might want to do that, you can't. You can't use same base. So you have to take logs of both sides. So I log both sides. All right. This time I have x's on both sides of the equation, so it's a little more complex. But the procedure is the same. It's just, it might take a little longer. Should have given you a little more room. All right, what's my next step? As soon as I log both sides, what does that allow me to do? What do the laws of logs say I can do now? I can bring the exponent down as a coefficient, right? Don't forget, like if you have a binomial, it's the whole binomial that's the coefficient, right? So I have to think of it that way. So 3x minus 1 equals log 5. minus x log 45. Again, I'm taking base 10s, so 3x minus 1 times log 5 equals minus x times log 45. Okay, because I have x's on both sides of the equation, sooner or later, I have to get my x's together so I can factor them out, right? So take a moment and I want you to kind of explore what you could do here with this question. See if you can figure out the next step or two. Okay, what was your next step? What did you do after this? What was your third line of work? Anyone? Someone must have done something. I saw a lot of scribbling going along and some calculator work. What did you do? What did you do? What was your next thing that you did? You divided by x? Minus x. Just to get the x on the other side? Then what? Then how are you going to get the x isolated from all that then? Okay, so then you end up putting them back here. Okay, so to avoid that, I'm going to show you another way, because then you end up kind of getting rid of him and putting him back. Did anyone else do anything different? I think that'll work, John. It's just to avoid that back and forth. What did you do, D?
Divided by both sides.
By x? So same thing as John did?
The other side and then log
Okay.
the other side.
The problem comes because you have x's in two places now, right? It's a little harder than the first one because you're not just isolating one, you got to get them both. So one of the strategies, and there are more than one of the strategies would be to get rid of the brackets again, right? To kind of release this x, because right now he's grouped with this -1. So I could do this, right? 3x times log 5 minus log 5 equals minus x log 45, right? I'll show you the strategy that I use a lot. Did anyone do that? Did multiply through? Okay, once I have that done, and then I'm going to check your way too, John. Once I have that done, I just take any term with an x, put it on one side, just like we usually do, and any term without x, put it on the other, right? Kind of congregate my x's on one side. So that means I'm going to have 3x log 5. He's going to stay here. And then I'm going to move my minus x log 5 over, so it'll become plus x log 45. And then over here, I'll just have my little log 5. And the reason he's all by himself, why is he all by himself over on this side?
Because there's no x.
There's no x, right? I'm just kind of, I'm grouping together my terms with x. Because then what I can do is I can factor my x out, right? That's the only guy I really want right now. I want to isolate him, so if I factor him out, that will give me 3 log 5 plus log 45 equals log 5. If you were doing a different strategy, continue on with your strategy. As long as we get the same answers in the end, it's fine. Okay, I have one last step to do. What's my last step? Divide by this whole piece, right? X equals, so I'll have log of 5 divided by 3 log 5 plus log 45. Just like in the previous question, when I did the previous question, anytime you have a complex fraction, meaning if I have more than one piece on the top of a fraction or more than one piece on the bottom, sometimes you have 2 on the top, 2 on the bottom, always use brackets for your numerators and denominators. So what I get, and John, I want you to check your answer and check it against mine, okay? So I have log of 5 divided by bracket 3 log 5 plus log 45. I got 0.186. Is that what you got? Perfect. I want to come over and see your method. Did anyone else get that as an answer that followed it through? Ryan, did you make your way through the whole question? Is that what you got too? Did you do it a different way? You'll end up being like a couple of decimals off maybe. Okay, let's try this one more. G, and then we gotta tackle E and H which are tough, okay? And then that'll be it for my examples today. And then I'll give you a little bit of homework, and I'll give you a little bit of time in class tomorrow to finish your homework too. I can't stress how important homework is. And judging by the lack of questions that I get, not everyone's doing their homework, right? Okay, how about this one? There's no way I can convert to same base, right? I've got base 3, base E. So I've got to log both sides. Now, is anyone thinking something different? What's my other option to logging? Log in base 10. Log base E. Anytime I see E, I'm tempted to use log and base E, and I think that's what I'm going to do. So I'm going to ln both sides, because something cool is going to happen if I do that. Okay? Because I can pick log or ln, and either one will work. It's just because I've done a few of these before. If you use ln, it makes your job a little easier. Because really, remember what the base is for ln? It's really this base E. Okay, so let's proceed. Now, as soon as I log both sides, my coefficients, or my exponents, come down to coefficient level. I get 3x plus 1 ln E, equals minus x ln E. Okay, now something really interesting happens. Remember what the base is here. Ln and base E of E, guess what that equals?
1.
Just 1, right? This whole thing just cancels out to 1. So negative x times 1, the whole term is gone. That makes your life a whole lot easier, right? So I'm going to put a little note here. Ln of E equals 1. Because there's the invisible E down here, right? So you're looking for the exponent in base E that gives you E. What's this? If I'm talking about logs, what would be the counterpart? If I had log, wouldn't it be log of 10 also equals 1? Isn't that true? Because 10 to the 1 equals 10. So remember those. Ln of E is 1, log of 10 is 1. All right, so let's keep going. This makes our job a little easier. Unfortunately, I still have to multiply through though, because I have x's on both sides. So the only way I can group the x's is if this guy is free, right, from his brackets. So I have the same situation as the problem above. I have x's on either side, so I want to group them and leave the term without an x. What do you want to do? Do you want x's on left-hand side or right-hand side? Do you want me to leave the x's on the left or the right? Right? Okay. So ln of 3 equals 3x ln 3 minus x. So I can factor an x out. And that leaves me with 3 ln 3 plus 1. Agreed? So let's just double check that. Or sorry, minus 1. All right, last step. To get x by himself, I just have to take my ln of 3 divided by 3 ln 3 minus 1. And now it's calculator time. Notice how I don't pick my calculator up till the last line when I have x isolated. And the reason is rounding is very important. And I know in science we do things differently, but in math we only round once at the very end. Okay? Because if I keep rounding every line, it reduces my answer. Whoops, this is ln of 3. So in my calculator, I'm going to press in ln of 3 divided by bracket 3 ln 3 minus 1, and my answer is 0.479. These questions take a long time to set up and to get x isolated. And the trickiest part probably is punching everything into the calculator right and making sure you don't miss any brackets, and that you punch it into the right order. Okay? All right. How are you guys feeling? Overwhelmed? We doing okay? Okay, we're going to tackle these last two guys, and they're probably the toughest, which is why I left them to the end. Now, does anything at this stage look different about them? Look at E. It says 2 times 7 to the exponent x minus 2 equals 100. And this is 5 times 3 to the exponent x plus 2 equals 2 to the exponent 2x plus 1. Neither of them are same base, for sure. What looks different about these two? Why do you think I saved these till the end? Any ideas? I mean, you're just guessing at this stage, right? If you've never seen these before, so I'm just curious about your guesses. The bracket around the 7, right? Abby, you said that? Because what's in front of the bracket? A 2, right? We've never had 2 kind of like a coefficient and a base. Same down here. You've got, it's a base 3, but you've got this coefficient. All the other ones just had 1 base, 1 base. That makes a difference. They're a little more complex. I don't think I left myself enough room, so I'm going to do this on extra paper, and I don't know if you want to try that too. But, because I think it might take us more room. So we've got 2 times 7 to the x minus 2 equals 100. I'm kind of excited about the 100 because it's a base 10 number. Maybe we could do some simplifying later. But I think everyone agrees there's no way I can make left hand and right hand same base. Agreed? So we have to log both sides. I don't see any e's in here, so I'm just going to log both sides like regular. Oh yeah, sure. Actually, you know what, John? That's a way better idea. I can get rid of the 2, right? Thank you. So what does that give me? Okay, now it's easy, right? Good job. You saved us an extra step or 2. Good for you, John. Okay, maybe I can do this one here. Okay, this should be easy for you now. Right? So go ahead, solve this one. Okay. So I got 4.010. Good job. Okay, so I've just kind of separated these out for my notes. Let's look at the very last question though. And then I promise you that's it for me talking today. Okay, so what do we have here? For sure I'm gonna need more work, or more room for work. So I'm gonna record mine on a different piece of paper. Okay, so I have 5 times 3 to the exponent x plus 2 equals 2 to the 2x plus 1. All right, I've got no way I can do same base. Can we do anything to simplify these first, John, though, like we did in the last time? I don't think so, right? And I have x's on both sides in the exponent, so this is definitely going to be tough. I don't see any base e's. If I saw base e, I would ln both sides. I don't see any e's, so I'm going to log. Okay, so I have to log both sides to release those exponents. But this extra coefficient creates a problem. Because if you look closely, look what you have here. You know what you have here first? Look very closely. You have this 5 and 3 actually is the mn situation here. It's an argument. It's an argument multiplication of factors. So the 5 is the m, the 3 is the n, and the n is the part with the exponent. The exponent isn't applying to the 5, is it? So therefore, first we have to separate into individual logs before we can apply the exponent rule. Yeah? No, you can't, because the exponent is only attached to the 3. And according to BEDMAS, we have to deal with exponents first, and then we could multiply. If the brackets, John, were around the 5 as well, for sure, then we can multiply the 5 and the 3, but the exponents only apply to the 3. Okay, so can you see why this is a tough one? Now, after this, I think you're good to go, meaning move forward, do what we did before. The exponents can come down as coefficients. So I'm going to give you a few minutes to work on this one because this is a tough one. So bring the exponents down, multiply through, x is on one side, non-x is on the other. This is going to be the toughest one and the longest one that you'll punch into your calculator for sure. I'm going to get you to, I'm going to assign page 50 for homework. I will give you a few minutes at start of class tomorrow to work a little more on it, but try and get a start on it, okay? Okay, let's see how everyone did so far. So, bringing my exponents down as coefficients, I get log of 5 plus x plus 2 log 3. Don't forget that it's a binomial you're bringing down, right? So bracket it off so you don't forget to multiply through appropriately, right? If you don't bracket it off, you'll forget to multiply. All right, I have to multiply through to get rid of my brackets, right? To get my x's outside the brackets so that I can start collecting like terms. Okay, at this stage, how many people got this far? Yeah? Now, x's to one side, non-x's to the other, right? It doesn't matter what side you leave your x's on. Traditionally, it seems to be students, well, traditionally we've had x's on the left, so I'll just do that. Okay, this log 2 can stay. So I've dealt with him, and I've dealt with him. These two guys have to move to the other side, right? So I'll have subtract log 5, excuse me, subtract 2 times log of 3. Agreed? One last step, I'm going to factor the x out. So x log 3 minus 2 log 2, right? I just divided the x out of each of these terms equals this whole mess again. These are just really tedious. There's so many terms to keep rewriting, right? To show my work. Okay, last step. It's this whole three-term monster, right? Divided by this piece. And notice how you never picked your calculator up until the very last step. Okay. This is a lot to punch into a calculator, right? Some calculators are friendlier than others. I don't have a super friendly one, neither does D, because we have to constantly look at the window and make sure we close our brackets off for logs. And this whole term has to be bracketed, so does the bottom. If you have 3 over 2, like anything other than 1 on 1, you have to use brackets. Bracket log 2 minus log 5 minus 2 log 3, close my numerator bracket, divided by, now my denominator in brackets, log 3 minus 2 log 2, and that means 2 times log 2, right? But my calculator understands that when I type in 2 log 2, it's 2 times log 2. Okay, after all that, hit equals, and I get x equals 10.823. Do I have any agreement? Neville, you agree? Carl? Yeah, you agreed? John and Ibby? Did you agree? Joanne? Ryan? Did you agree? Rahel, did you finish it? Not yet? Okay. Dee and Brahim, did you finish it yet? Okay. See if you agree with that. It seems to. Now, what does that mean? That means that the variable has to be 10.823 approximately, right? That's a rounded answer. But if I substitute that value in for x, that will make my left and my right hand equal. Okay? So you can see how complex, can you see how complex these equations are? Wasn't it so much simpler when we could convert to same bases? Look at the work I had to show. 1, 2, 3, 4, 5, 6, 7 lines of work before the answer, right? We never had that in same base. But it tells you how complex logs are, how powerful they are. They helped us solve a really, really difficult equation, right? Okay, your homework is page 250. Please start on it. I will give you about maybe half an hour at the beginning of class, maybe a little longer to finish it up. It starts with the tough ones and then goes to the easier ones. You might want to reverse that, right? You might want to start with these and save these for tomorrow, considering I'm giving you class time. But regardless, please start some homework.